What is 3D printing? 3D printing or additive manufacturing is a process of making three-dimensional solid objects from a digital file. The creation of a 3D printed object is achieved using additive processes. In an additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced cross-section of the object. 3D printing is the opposite of subtractive manufacturing, which is cutting out, hollowing out a piece of metal or plastic with, for instance, a milling machine. 3D printing enables you to produce complex shapes using less material than traditional manufacturing methods. How does 3D printing work? It all starts with a 3D model. You can opt to create one from the ground up or download it from a 3D library. 3D software. There are many different software tools available, from industrial grade to open source. We've created an overview on our 3D software page. We often recommend beginners to start with Tinkercad. Tinkercad is free and works in your browser. You don't have to install it on your computer. Tinkercad offers beginner lessons and has a built-in feature to export your model as a printable file, e.g., STL or OB. Now that you have a printable file, the next step is to prepare it for your 3D printer. This is called slicing. Slicing. From printable file to 3D printer. Slicing basically means slicing up a 3D model into hundreds or thousands of layers and is done with slicing software. When your file is sliced, it's ready for your 3D printer. Feeding the file to your printer can be done via USB, SD or Wi-Fi. Your sliced file is now ready to be 3D printed layer by layer. 3D printing industry. Adoption of 3D printing has reached critical mass as those who have yet to integrate additive manufacturing somewhere in their supply chain are now part of an ever-shrinking minority. Where 3D printing was only suitable for prototyping and one-off manufacturing in the early stages, it is now rapidly transforming into a production technology. Most of the current demand for 3D printing is industrial in nature. Acumen Research and Consulting forecasts the global 3D printing market to reach $41 billion by 2026. As it evolves, 3D printing technology is destined to transform almost every major industry and change the way we live, work, and play in the future. Examples of 3D printing. 3D printing encompasses many forms of technologies and materials, as 3D printing is being used in almost all industries you could think of. It's important to see it as a cluster of diverse industries with a myriad of different applications. A few examples: consumer products, eyewear, footwear, design, furniture. Industrial products, manufacturing tools, prototypes, functional end-use parts, dental products, prosthetics, architectural skill models, maquettes, reconstructing fossils, replicating ancient artifacts, reconstructing evidence in forensic pathology, movie props, rapid prototyping, rapid manufacturing. Companies have used 3D printers in their design process to create prototypes since the late 70s. Using 3D printers for these purposes is called rapid prototyping. Why use 3D printers for rapid prototyping? In short, it's fast and relatively cheap. From idea to 3D model to holding a prototype in your hands is a matter of days instead of weeks. Iterations are easier and cheaper to make, and you don't need expensive molds or tools. Besides rapid prototyping, 3D printing is also used for rapid manufacturing. Rapid manufacturing is a new method of manufacturing where businesses use 3D printers for short-run small batch custom manufacturing. Automotive. Car manufacturers have been utilizing 3D printing for a long time. Automotive companies are printing spare parts, tools, jigs and fixtures, but also end-use parts. 3D printing has enabled on-demand manufacturing, which has led to lower stock levels and has shortened design and production cycles. Automotive enthusiasts all over the world are using 3D printed parts to restore old cars. One such example is when Australian engineers printed parts to bring a Delage Type C back to life. In doing so, they had to print parts that were out of production for decades. Aviation. Aviation loves additive manufacturing, largely due to the promise of lightweight and stronger structures offered by 3D printing. We've seen a whole bunch of innovations in the domain of aviation lately, with the appearance of more critical parts being printed. Turbine center frame. One such large component printed this year was the turbine center frame, which was printed by GE as part of the EU Clean Sky 2 initiative. The Advanced Additive Integrated Turbine Center Frame (TCF) is a 1 meter diameter part printed in nickel alloy 718 by GE and a consortium from Hamburg University of Technology, TU Dresden, TUD, and Autodesk. It is one of the largest single metal parts printed for aviation. Typically, components like this are manufactured using casting and consist of multiple parts. In the case of the 3D printed version, it was reduced from an assembly of 150 parts down to just one single piece. The printed version also benefits from a reduction of both cost and mass by 30% and a reduction in lead time from 9 months to just 10 weeks. Metal parts certified by ESA. Back in June 2022, it was reported that Lufthansa Technik and Premium Aerotech had created the first load-bearing metal part that had been approved for use in aviation. The new link was produced using LPBF and had demonstrated higher tensile strength compared to the traditionally forged version. The part was made at Premium Aerotech's facility in Varel, Germany, and a large number of test parts were printed and tested to ensure quality and repeatability for certification. Printing the part represented a cost saving for the component and set the stage for using this manufacturing method for creating structurally important metal parts in the future. It was also used to test the process and to demonstrate the certification process of load-bearing parts. Hypersonic fuel injector. This next printed item was never destined to be fitted to an aircraft, but rather it was designed to be installed in a facility for testing flow conditions at hypersonic speeds. When flying in the hypersonic flight regime above Mach 5, the air passing around the vehicle becomes incredibly hot and the pressure increases significantly. These conditions can cause the air itself to become chemically reactive, which causes issues for fuel-burning vehicles. Simulating flow conditions with CFD is computationally expensive, if not impossible, and so to replicate the flow conditions, researchers at Purdue fabricated a giant burner to recreate the hot, fast, high pressure experienced in hypersonic flight. In short, they basically built a rocket nozzle and they placed the test components in the exhaust plume to see how they performed. The injectors that they printed feed fuel and air into the combustion chamber to create specific turbulent flow fields and a stable flame. The injectors were printed with Haste Alloy X, which is a superalloy with superior temperature resistance. The team printed multiple different injectors in rapid time, and tested them all in the burner to see which performed the best. Now they are able to replicate the hypersonic conditions for flight on Earth at a fraction of the cost and risk associated with doing it miles above the Earth's surface. This can benefit fast aircraft such as scramjet-powered vehicles as well as space vehicles. Relativity Space. We have covered US-based rocket printing company Relativity Space quite a lot on this website. From their super large metal printer the Stargate to the rocket themselves, this company has been doing big things with both printing and rockets. The 4th General Stargate 3D printer is capable of printing objects measuring 120 ft long and 24 ft in diameter, and 12x faster than their previous printers. The new AI-assisted robotic printer has been able to achieve faster printing speeds thanks to its innovative multi-wire print head. This print head allows for multiple metal feedstock wires to be fed into it at the same time, resulting in higher deposition rates. The company is scheduled to make their first LEO test flight of the printed Turan 1 rocket this month of January 2023, so we just thought we would give them an honorable mention in this article as a reminder. You can see the Turan 1 undergoing a hot fire test in the video below. Construction. Is it possible to print a building? Yes, it is. 3D printed houses are already commercially available. Some companies print parts prefab and others do it on site. Most of the concrete printing stories we look at on this website are focused on large-scale concrete printing systems with fairly large nozzles for a large flow rate. It's great for laying down concrete layers in a fairly quick and repeatable manner. But for truly intricate concrete work that makes full use of the capabilities of 3D printing requires something a little more nimble and with a finer touch. Consumer products. When we first started blogging about 3D printing back in 2011, 3D printing wasn't ready to be used as a production method for large volumes. Nowadays there are numerous examples of end-use 3D printed consumer products. Footwear. Adidas 4D range has a fully 3D printed midsole and is being printed in large volumes. We did an article back then, explaining how Adidas were initially releasing just 5,000 pairs of the shoes to the public, and had aimed to sell 100,000 pairs of the M-infused designs by 2018. With their latest iterations of the shoe, it seems that they have surpassed that goal, or are on their way to surpassing it. The shoes are available all around the world from local Adidas stores and also from various third-party online outlets. Eyewear. The market of 3D print.